Hello students, a warm welcome to all of you at AriserTalent. So, we were on the second chapter of our class 10th chemistry, that is acids, base and salt, and until now we have discussed many of the topics regarding acids and bases. In our previous lecture, we have discussed about the pH of a solution and the basic introduction part of the bases. Now, in today's lecture, our today's topic is classification of the bases. As we have done the classification of the acids in the similar manner, we were discussing about now the classification of the bases. So, our today's topic is classification of bases. So now, classification of the bases is done similarly to that of the acids, depending upon their strength, depending upon their concentration, and it also depends upon the acidity of the bases. So we have the three classifications in this category. So our first classification will be on the basis of strength. Second classification will be on the basis of concentration. And third classification will be based on the acidity of the bases. So, these are the three characters of discussing the classification of the bases on the basis of these three factors. Now, we will deal with these three factors one by one. So, according to the strength, according to the concentration, and according to the acidic character. Now, we have again further classification of the bases according to these three categories. So, our first classification on the basis of strength will be, we have two acids, that is strong bases and weak bases. Is it all right? Now, we are on the next topic, that is concentration. On the basis of concentration, we have again two type of bases, that is concentrated one and the diluted one. So, our two categories here are concentrated and the second category will be diluted. So, these are the two categories depending upon the concentration of the acids. Now, we are on our third category, the classification of the bases according to their acidity. So, on the basis of acidity, the bases are categorized into the three groups, that is monoacidic, diacidic and triacidic. So, again we have the three classification here, and these are monoacidic, diacidic and triacidic. So, again we have three categories, monoacidic, diacidic, and our third category is triacidic. So, we have the classification of the bases according to these three categories, that is strong one and weak one. On the basis of concentration, we have concentrated and diluted. And again on the basis of acidity, we have the three perspectives, that is monoacidic, diacidic and again triacidic. So, this is the basic characterization or the flow chart related to the classification of the bases. Now, we are starting our topic, that classification of the bases on the basis of strength. On the basis of the strength, we have basically two type of bases, that is the strong one and the weak one. So, our first category is classification on the basis of strength. So, we are going to start our first topic, that is classification on basis of strength. So on the basis of the strength, we have our first category, that is strong bases and weak bases. So the name indicates strong bases are basically those bases which have a tendency to give larger amount of OH minus ions in their aqueous solution. It means if the base have a tendency to release larger amount of OH minus ions, we can say that the base is strong. If the base is having a less tendency to give OH minus ions, we can say that it is partially or incompletely ionized in its aqueous solution. So this category is termed as weak bases. In both the categories, we have certain example which might tell you how strong the base is. So now we are on our first description, that is strong bases. So the compounds which are completely ionized in their aqueous solutions to give hydroxide ions are termed as strong bases. So it means strong bases are completely ionized in the aqueous solution. So we can term these bases as a strong bases. We have few examples in the category of the strong bases, and these examples are as follows. Firstly, the example here we are taking of NaOH. NaOH is basically referred as caustic soda. So NaOH will dissociate into Na plus OH minus. So you can see here, this will give a complete ionization in the aqueous solution and the hydroxide ions are obtained here. Now we have our second example, that is KOH. KOH is caustic potash. OH stands for caustic and K stands for potash. So again it will give K positive plus OH minus ions. Now we are taking our third example. Our third example is barium hydroxide. Barium hydroxide dissociate in the aqueous solution to give Ba plus 2 plus OH minus ions. Now what happens in this case? You can easily observe that these three compounds on complete ionization is going to produce OH minus ions. So we can say that these are the examples of strong bases. So this is all about the strong bases. Now we are coming to our next category, that is weak bases. Weak bases are those substances which are partially dissociate in the solution to give OH minus ions. It means there will not be the complete dissociation of the ions. So our next category is strong bases. So now we are moving to our next category, that is weak bases. So our next topic is weak bases. So as we have discussed in the strong bases, the compounds which are completely ionized in the aqueous solution to give OH negative ions are termed as strong bases. So in the similar way, we can write the definition of the weak bases as the compounds which are partially ionized in the aqueous solution to give OH minus ions are termed as weak bases. So it means weak bases have a tendency to partially ionized. So these are partially ionized in aqueous solution to give OH minus ions. So this is all about the definitions regarding weak bases. Now we have few examples in this category. The examples I am writing here. So we have here examples of weak bases. So we have first example in the category of the weak bases, that is NH4OH. NH4OH is basically the ammonium hydroxide. It dissociates into NH4 positive plus OH negative. It means it is giving the hydroxide ion, but this will give the hydroxide ion in the lower concentration. It means the probability of ionized in the aqueous solution is not complete, it is partial. So we will get partial hydroxide ions here. So it is considered in the category of the weak base. Now we are moving to our next example, that is CaOH whole twice, that is Ca plus 2 plus OH negative. Again this will give the partial hydroxide ion, so I will consider it in the category of the weak bases. So I hope this topic has been clear to you, that what is the basic difference between the strong bases and weak bases. I am repeating the definition again. Strong bases are those compounds which are completely ionized in the aqueous solution. On the other hand, weak bases are those compounds which give the partial dissociation in the aqueous solution. Now we are on our next category, that is depending upon the concentration how bases are classified. So on the basis of concentration we have two type of bases again, that is concentrated one and diluted one. But before proceeding to this, you can copy it from here. Now our second category will be classification on the basis of concentration. So our next classification will be on the basis of concentration. If you want to make any substance diluted or concentrated, so if you want to make something diluted, add as much of the water as can possible, so the solution will be diluted in nature. If I am saying any compound contain higher concentration of the base or alkali, then it is said to be the concentrated one. If it contains less amount of alkali, more amount of water, I can say the solution will be the diluted one. Dilution means adding water to the compound to make it diluted. So we have again two categories here. Our first category is concentrated bases and second category will be the diluted bases. So concentrated bases are those which have larger amount of alkali and less amount of water. So these are the 2 points regarding the concentrated bases, that it contains larger amount of alkali and less amount of water. Now we are moving to our next category, that is diluted bases. what happens in the case of diluted bases? Diluted bases contain less amount of alkali and more amount of water. So it is just opposite of this. It contains less amount of base or alkali and on dilution it contains more amount of water. So it is all about the difference between the concentrated acids and the diluted acids. Concentrated bases and diluted bases. Now there are the two differentiating categories, first on the basis of strength and second on the basis of concentration. Now we are moving to our third category of the bases, that how bases are defined on their acidity. Acidity means the capacity to release OH minus ions in the aqueous solution. It means having the tendency to dissociate into OH minus ions. If the substance will give one hydroxyl ion on aqueous solution, on dissociation in the aqueous solution, we can term it as a monoacidic. Mono means single. If it is having a probability of giving the two OH minus ions, we can call it as a diacidic. If it have a tendency to give the three hydroxyl ions, so we can see that it is triacidic in nature. So it is the definition related to OH minus ions. Similarly, we can compare it with the H plus ions. If one H plus ion react with two OH minus ions to give salt and water, we can consider it as a monoacidic. But if two H plus ions reacted with certain acid and give salt and water, so we can say that it is considered in the category of the diacidic one. So it is on the basis of OH minus ions and H positive ions. Now we are moving to our third category, that is based on the acidity. Now we have our third category, that is classification on the basis of acidity. So on the basis of the acidity, we have our first category, that is monoacidic one. So we are on our first category, that what are monoacidic bases. So monoacidic bases are those bases which have the tendency to give only one OH minus ions in the aqueous solution. So here definition it is tendency to give one OH minus ion in aqueous solution. So this will be the basic definition for monoacidic bases. We have another definition also with respect to H plus ions, and this definition is capacity to combine with one H positive ion to give salt and water. So this will be the another definition for the monoacidic bases in terms of OH minus ions and H plus ions. Now we will understand this with the help of an example here. The example here in this category is, firstly I am taking the same example, NaOH, then we have KOH. Now when NaOH is dissociate in the aqueous solution, it is going to give Na positive and OH minus. So here Na plus and OH minus. Again this caustic potash will give K plus OH minus. Now what we are observing here, we can see here only one hydroxide ion is dissociate in this solution. The quantity of OH minus ion here is 1. Again in this example we have the 1 OH minus ion. So I can say that this is considered in the category of monoacidic bases. Mono means single. So we are getting only single ion here. So I hope this has been clear to you what are monoacidic bases. Now we are going to our next category, that is the diacidic one. So our second topic is diacidic bases. As the name indicates, the diacidic bases have a tendency to release 2 OH minus ions in their aqueous solution. So here definition will be, they will give 2 hydroxide ions. Two hydroxide ions in aqueous solution. So now this will be clear to you with the help of an example. So we are considering an example for diabasic one. So here we will have an example of diabasic acids. Diacidic bases. We have first example, that is calcium hydroxide. So calcium hydroxide is CaOH whole twice. CaOH whole twice will dissociate into Ca positive plus 2OH negative. Now I am taking next example, that is CuOH whole twice, that is copper hydroxide, and this copper hydroxide will dissociate into Cu plus 2 and again 2OH negative. Now you can easily observe here in the product side, after the dissociation of the ions in the aqueous solution, what we are getting? We are getting 2 hydroxide ions here and 2 hydroxide ions here. So I can say that this will be considered in the category of diacidic one, because diacidic bases are those which give 2 hydroxide ions. So this will be the category of the dihydroxide one. Now after discussing monoacidic and diacidic, we are moving to our third category, that what are triacidic bases. So our next topic will be triacidic, but before you can copy it from here. So now our third category will be the triacidic bases. So the next acid is triacidic bases. As the name indicates, triacidic bases are those bases which have the tendency to release 3 hydroxide ions in the aqueous solution. So here the basic definition is tendency to release 3 hydroxide ions in aqueous solution. Now the 3 hydroxide example we will understand by this. So we have again example in this category. So the example for triacidic bases is, we have aluminium hydroxide, that is AlOH3 whole thrice. Now it dissociates into Al plus 3 having a valency 3, and it is going to give 3 OH minus ions, that is 3 hydroxide ions. So you can see here after dissociation of aluminium hydroxide, we are getting 3 hydroxide ions here. It means these 3 hydroxide ions will be considered in the category of triacidic bases. Tri means 3 and we are getting 3 hydroxide ions here. So I hope this topic has been clear to you, how the classification of the bases will be done on the basis of their acidity. Now we are moving to our next category, that how will be the conduction occurs in case of acids and bases. So our next topic will be the conduction of acids and bases. So you can copy it from here firstly. Our next topic is conduction through acids and bases. Now, before starting the conduction through acids and bases, we will discuss the simpler things about this topic. Firstly, acids are those substances which have tendency to release H positive ions in their aqueous solution. On the other hand, bases are those substances which have the tendency to give OH minus ions in their solution. So you can see here, after dissociation of the acid and base, what we are getting here, we will probably getting the ions. And we also know that ions have a tendency to pass the electric current through their solution. So we will do a simple experiment to understand the conduction through acids and bases. So for this, we will do a simple activity here. So firstly, what we have done here, we will take a beaker. We will take a beaker here. Now, what we are doing in our next step, we are filling this beaker with the HCl solution. So, in this beaker, we have taken a hydrochloric acid. Now, we will take a 2 iron nails that are standard on the rubber cork. So, in our next category, we have taken a rubber cork, and what we have done here, we have inserted 2 iron nails here. Now, we will trying to connect these iron nails with a 6-volt battery attached to a bulb through it. Now, what we are doing here, we have taken a 6-volt battery, and this 6-volt battery will be connected through a bulb. Now, this will be connected to a switch. We have applied switch here. And in this system, it is again connected to the iron nail. Now, this is the system we have taken for the conduction through acids and bases. Firstly, we have taken a beaker here. So, this will be the beaker. In this beaker, we have taken a HCl. That is dilute HCl, which means hydrochloric acid. Now, here we have taken a battery. This battery is connected through a bulb. Then we have applied a switch here. in this system, we have taken a rubber cork. On this rubber cork, we have established the 2 iron nails. So here it is. Rubber cork. In this system, we have taken a 2 iron nails. So you can see the system here, and I hope the components I have taken here will be easier to understand by you. Now what we are doing in this system, suddenly we will press the switch, that the key that we have applied. After switching on the key, what you have observed that we are provided with iron nails and HCl. So soon the bulb will start glowing. The bulb will start glowing as electric current is passed through it. What actually happens in this case, we have taken a hydrochloric acid in the beaker. As soon as the current is passed through it, the substance dissociate into H positive and Cl minus ion. These ions will start moving in the solution and help the bulb to glow. So what happens in this case here? As the key is pressed, if the key is pressed, electric current will start flowing through it. Then after flowing of the electric current through the solution, the bulb will start to glow. So our second point will be, bulb will start glow. Now what happens in this case? Now we have taken a HCl in the container and it dissociates into H positive and Cl negative ions. So our third point will be, HCl will going to dissociate into H positive and Cl minus ions, and these ions will do the conduction in the solution. These both ions are responsible for the conduction in the solution. So we can say that acids and bases have a tendency to pass current through them and help in the conduction. Similarly, if I take another acids like H2SO4 and if I am taking base NaOH in the solution, so it will also pass the electric current through it. Now, if I pass glucose or ethanoic acid or ethanol through this solution, the conduction will not going to happen because this will not dissociate into ions and will not help in the passage of electricity through this solution. So what happens in this case? If I am taking glucose, glucose is C6H12O6, and secondly we have taken ethanoic acid. Ethanoic acid is basically C2H5OH. So instead of HCl or H2SO4, if I am taking glucose and ethanoic acid, the conduction will not going to happen because this will not dissociate into ions. So conduction will not be possible in both the cases. So in our today's lecture, we have discussed about the classification of the bases and conduction through acids and bases. So this lecture is over for today and we will deal with many more topics in our next lecture. Thank you so much and have a nice day.